Today, we will start to discuss data analysis. This is for quantitative studies, and we will discuss qualitative studies later. First, let's talk about descriptive statistics. Remember that we discussed the population and sample in Chapter 6. A parameter is a numerical or graphic way to summarize data obtained from a population. A statistics is a numerical or graphic way to summarize data obtained from a sample. There are two main types of numerical data you might utilize. First, categorical data is obtained by determining the frequency of occurrences in each of several categories, such as gender and ethnicity. Then, quantitative data is obtained by determining placement on the scale that indicates either amount or degree, such as test scores and GPA. Quantitative data are usually reported in the form of scores. Raw scores are the initial scores that you obtain. It could be the number of questions answered correctly in a test. It could be the sum of scores of each individual item in a survey. Often, a raw score is difficult to interpret. For example, you want to compare one student's test score with others, and the number of questions answered correctly has little meaning in this instance. Thus, derived scores are needed. Derived scores are taken from the raw scores and converted into more useful scores on some type of standardized basis. Such scores enable researchers to say how well one individual performs compared to others taking the same test. Examples include age and grade equivalent scores, percentile ranks, and standard scores. In most cases, standard scores are the best scores to use. There are different techniques for summarizing quantitative data. We will go through these one by one. Frequency polygons place data in some sort of order. A frequency distribution lists scores from high to low. A grouped frequency distribution groups scores into intervals, but the information cannot be visualized in a table. So, we use what's called a frequency polygon to develop a graphical display of frequency. This can be useful in comparing scores in two or more groups. This is an example of a frequency table. Technically, the table should include those with zero frequency. We have eliminated those to simplify the presentation. The table is a bit hard to read or to glean useful information. This is an example of a grouped frequency table. We group scores into intervals of 5. Note that you can create frequency tables for categorical data, such as frequency of boys and girls. This is a frequency polygon of two methods in one study. It is easy to see the difference between the two groups for each score interval. A histogram is a bar graph that is used to display quantitative data at either the interval or ratio level of measurement. A stem and leaf plot looks like a histogram except instead of bars, it shows values for each category. These are helpful for comparing and contrasting two distributions. Here is an example of a histogram. The stem and leaf plot is similar. It shows values in the graph. Imagine that we can even add another group to the histogram with different colors of bars to show differences between two groups. Normal curve. This distribution curve shows a generalized distribution of scores instead of straight lines like with frequency polygons. The distribution is bell-shaped and symmetrical. The large majority of the scores are in the middle of the distribution, and the scores decrease further away from the middle. It is based on a precise mathematical equation. We will not cover that in this course. We will discuss a bit more about the curve later in this presentation. Here is a figure of normal curve. Next, let's discuss measures of central tendency. We will define mean, median, and mode. It is easy to calculate these numbers. They enable researchers to summarize the data in a meaningful way. Mode is the most frequent number in the data. It is 62 in this example. Median is the middle number or the 50th percentile. We can estimate other percentiles if you want to know where a specific test score falls in a group. Normally, researchers are interested in the 25th and the 75th percentiles, also called first and third quartiles. These scores are not influenced by outliers since they depend on the position of a score distribution. In this case, it is 64.5. Mean is the average value of all the scores. Next, let's talk about variability. It refers to the extent to which the scores on a quantitative variable in a distribution are spread out. First, the range represents the difference between the highest and the lowest scores in a distribution. A five-number summary reports the lowest, the first quartile, the median, the third quartile, and the highest score. This summary gives you a useful set of numbers in order to provide a general overview of the data. It is often portrayed graphically using box plots. Here is an example of box plots for Class A and Class B. You can see some basic information regarding the scores in two classes. For instance, the highest score of Class A is 85 and the highest score of Class B is 75. Standard deviation is considered the most useful index of variability. It is a single number that represents the spread of a distribution. The more spread out scores are, the larger the standard deviation will be. When you conduct data analysis, data variation is necessary to identify the study effect. This slide shows you how to calculate the standard deviation. The mean value is required to calculate the standard deviation. As you can see from the formula, standard deviation is the amount of variation or dispersion for the test scores from its mean. You are not required to know how to calculate any of these values in this course. Focus on the conceptual understanding of each concept. Standard deviation is related to normal distribution. Please check the 68, 95, 99.7 rule. Standard scores use a common scale to indicate how an individual compares to other individuals in a group. The simplest form of a standard score is a z-score. A z-score expresses how far a raw score is from the mean in standard deviation units. Standard scores provide a better basis for comparing performance on different measures than do raw scores. T-scores are z-scores in a different form. There are other standard scores as well. Here is an example to help you understand how each of these different types of standard scores are related to each other. Here you can see percentile ranks. You can see z-scores, t-scores, and then some common test scores you might be familiar with. Correlation is a very common measure that you can see reported in research studies. When you conduct a research study, you hope to determine whether a relationship exists between two or more quantitative variables. The scatter plot can help you with your comprehension of such relationships. You may see outliers on a scatter plot. Such scores divide or fall considerably outside most of the other scores in a distribution or pattern. They indicate an unusual exception to a general pattern. We may exclude outliers from data analysis. Correlation coefficient is the degree of relationship between two sets of scores. It is important to note that it only demonstrates that a relationship exists. It cannot indicate any causal relationship between variables. The most commonly used correlation coefficient is the Pearson moment product coefficient. Here is an example of a scatter plot with an outlier. You can see a positive relationship between family cohesiveness and achievement scores. Here are examples of scatter plots with different correlation coefficients. Correlation coefficients range from -1 to 1. We are going to look at some nonlinear or curvilinear relationships. Next, we are going to introduce some basic methods to summarize categorical data. As mentioned above, we can use frequency tables to display categorical data. A bar graph shows the percentages of different types of learning activities. It is easy to compare the frequency of usage this way. A pie chart shows you similar information. It is a personal preference to decide which graph to use. Finally, we can use contingency tables to report relationships between two or more categorical variables. This is the end of this lecture.